Okay guys, so let's go ahead and get started with graph in motion. This one right here that we have is distance time graph, which is referred to sometimes as position. So then I put position right here. Right here I'm going to put meters. So then it's going to be, or I drew these lines right here to say how far I am away from the starting point. So then I said, okay, this is going to be 10 meters, another 10 meters, so 10 meters, 20 meters, 30 meters, 40 meters. So right here, a minute goes by, I'm still 40 meters away from home. Another minute goes by, I'm still 40 meters away from home. I'm still 40 meters away from home. So then that means that I'm in the same location throughout the whole period of time, throughout my 1, 2, 3, 4, 5, 6, 7 minutes. So then I say that I am at rest. Forces are balanced. The object is at rest. So then here we put it rest, constant. We could say that it's going, or that the object is at 0 meters per minute and forces are balanced. The second example that we have right here, we have again position. So we are 10 meters, 20, 30, 40, 50, 60, 70 meters. And then over here we have 1 minute, 2 minutes, 3 minutes. So then right here I could say that at 1 minute, I'm 10 meters away from the starting point. Another minute passes by, I'm another 10 meters away from home. So now I'm at 20 meters away from home. Another minute goes by, now I'm 30 minutes away from home. So during the period of a minute, I move away 10 meters. So this is constantly 10 meters, 10 meters, 10 meters within the period of every minute. So then we say that for the forces are balanced. I'm going at a constant speed. Over here is at rest because I remain at that same place for the whole period of time. Here I am moving away. Okay, I'm moving away from the starting point. So then constant speed. In distance graphs, when you see a slope, a line at an angle, that's going to be that the object is traveling at a constant speed. The steeper the slope, the faster the object is moving. The less of the slope, then that means that I am going slower. So this is constant speed. So we say constant speed, forces are balanced, moving away from home because we started at 0 meters, then we go 10 meters away from home, 20 meters away from home. So constant speed. Now, let's go ahead and look at the next one. For the next one, we have, if this was, let me see, 10, 20, 30, 40, 50, 60, 70. If this is 70 meters away from home, then in 1 minute passes and now I am 50 meters. Let me see, 10, 20, 30, 40, 50, 60, 70. So now I'm at 60 meters away from home in 1 minute. In another minute, now I am 40 meters away from home. And then I'm 30 meters. Another minute, I'm 20 meters. So then what's happening is that I am returning back to the starting point. And again, I am coming at a constant speed because you still see my slope right there. I still see that straight line. So then we say that we're going back home or back to the starting point. Forces are, it's going at a constant speed and forces are balanced. So constant, back to home, and forces are balanced. Now we're going to go to the last example. And as you can see on the last example, we do not have that straight line. We don't have that slope. Instead, we have a curved line. So that means that the line right here is not much of an angle. So then it started slow and then the object sped up. So it was kind of like, so right here we say force, the object speeding up, it's accelerating and forces are unbalanced. So here we have accelerating, increasing the speed, and forces are unbalanced. Now, let's go ahead and go to the next type of graph. The next type of graph is what we call the speed or velocity graph. Okay, so it could be speed, velocity is the same thing, so they might put speed and velocity, or they might put just speed or just velocity. So with these, it's kind of like how fast am I going? I think about a speedometer, kind of like the ones that measure the speed in the vehicles when your parents are driving. So then right here again, I put my little marks. This is 10, but now it's not 10 meters away from home. This is, I'm going 10 miles per hour. No, not miles. 10 meters per minute. So I'm going 10 meters per minute, 20 meters per minute, 30 meters per minute, 40 meters per minute, 50 meters per minute. But as you can see right here, this object, it's going 10, 20, 30, 50 meters per minute. So it's going 50, 50, 50, 50, 50 meters per minute, 50, 50, 50, 50. And when we look at the speedometer remains right here. The needle remains right here at 50. So that means that the object is traveling at a constant speed. So we say the car's going, or the vehicle or the object is moving at a constant speed. It remains with the same speed. Example, going 40 meters per minute, and forces are balanced. So let's go ahead and look. Oh, and let me go ahead and show you right there. I'm sorry. So then we go again. Constant speed, same speed. Example, 40 meters per minute, and forces are balanced. On the next example, we have, again, now we have the slope. When we were talking about distance, the slope represented that I'm going at a constant speed. Now here, when we're talking about speed, just think about the speedometer, okay? So then as I say 10, 20, 30, 40 meters per minute. So then right here, my speed is increasing. It's going 10, 20, 30, 40, 50, 60, 70, 80, 90. So then right here, as we move up and as we move out at this line, we say here the object is accelerating, is speeding up. Because at 1 minute, it's 10 meters away from home. I mean, not 2 meters away from home. I'm sorry. The speed. 1 minute is going 10 miles per hour. Another minute, now it's going 20. Now it's going 30. It's not that it's going, taking a minute and it's traveling the same amount of time. No, when you see the speedometer is going up. It's going up. So speed is increasing. So if the speed is increasing, then we're talking about accelerating. So here, that slope is acceleration. Again, the steeper the slope, the higher the acceleration. That means that the object's moving faster. The less steep the slope, that means that it's accelerating, but it's going slower. So then right here, we say it's acceleration, speeding up, and forces are unbalanced. We're going to go to the next one, okay? On the next one, we see something else happening. We see now that the line is going down, similar to what we had over here. But over here, the object was going back home and it was going at a constant speed. Here, the object is slowing down because my speed, if it was going at 70, now my speed, a minute later, it'll be going at 60. A minute later, now the car's going 50. So then it's kind of like, if I'm going from 30 to 20 to 10, that means that now my speed is slowing until I get to 0. So then we say that the object is accelerating. It's slowing down. So then we have acceleration. We call it negative acceleration right here because the speed is decreasing. Okay, so here we go. So speed decreasing. So then this is what we have on motion graphs. I don't know if I said it at the beginning, but this is page 37 from your book. I'm gonna stop the video right here, and then we're going to go into the questions. Okay, thank you. See you all.